We were going to talk about ionic strength. So previously, we said that in diverse ion effects, the presence of inert ions increases the solubility of our substances. Okay, so specifically, uh, we said that. Okay, this is the slide. Okay, so when we have higher ionic activity, we get less precipitation or increase solubility. Okay, so last time I told you that this ionic activity refers to the concentration of your diverse ions. Okay, so how are you going to quantify the concentration of your diverse ions in solution? So we're just going to use this equation. This is mu, the symbol for ionic strength, equal to 1/2 of the sum of the product or the molarity of your diverse ions times their respective charge. Okay, so that means if we have, let's say, um, potassium nitrate solution that dissociates into potassium ion and nitrate ions, the expression for ionic strength becomes 1/2 the sum of the products of the concentration of your ions and their charges. So that means that is the concentration of potassium ion times their charge. What is the charge of potassium ion? It's positive 1 squared, plus the concentration of nitrate ion times its charge squared. Okay, so let's have some practice. So I'm going to answer two problems. Okay, A and B. A and B. Okay, so for letter A, I'm going to change the color. Okay, so for letter A, we have sodium nitrate. So for sodium nitrate, let's write the dis- dissociation reaction. Dissociates into sodium ion and nitrate ions. So if we have 0.1 molar, this one, that means we have 0.1 molar of sodium ion and 0.1 molar of nitrate ions, and that is given by the stoichiometry. So that means to solve for the ionic strength, that is mu equals 1/2 the concentration of sodium plus times its charge, it is positive 1 squared, plus the concentration of nitrate ion times negative 1 squared, its charge squared. Solving for that, that is 1/2 times 0.1 molar times 1 squared is still 1, plus concentration of nitrate ion is 0.1 times negative 1 squared is 1, so 0.1 times 1 is still 0.1 molar. Solving for this, the ionic strength for the sodium nitrate solution is 0.1 molar. Okay, so let's try sodium sulfate. Okay, so for sodium sulfate, we're going to write the dissociation reaction. So that's sodium sulfate dissociating into 2 moles of sodium ion plus 1 mole of sulfate ion. So if we have 0.01 molar of this, based on stoichiometry, we will have 0.02 molar of sodium ion and 0.01 molar of sulfate ion. So to solve for the ionic strength, that is just mu equals 1/2 times the concentration of sodium times positive 1 squared plus concentration of sulfate, anyway, times negative 2 squared. That's mu equals 1/2 times 0.02 times 1 is 0.02 molar plus 0.01 molar times negative 2 squared is 4. Okay, so That means mu is equals to 1/2 of 0.02 plus 0.04 molar, and that is equal to 0.03 molar. So that's how you solve for the ionic strength.